Hello everyone, welcome back to my channel. I am going to speak about the function today in very abstract term right now. So end of this video, you should have an idea of what a function really is. For this, first I am going to show you a relevant example like this. In this machine, 4 is inserted, that is input, and 16 is the output. And again, 5 is inserted here as a input, and 25 is output, and finally as a input, then 36 is the output. Right now from here we can say that every input has a unique output. There is another example also, the 6 times, all right, input and output process. The 6 times 3 is 18, 6 times 5 is 30, and 6 times 7 is 42. Now this machine gives us output for the given input. Now look at an arrow diagram to represent the relation. Looks like this is how we can say every input in the set A has a unique output in set B. Now what is function? In simple word, a function is a special relation. It produces a new elements in output out of some given element in input. Let's understand it in terms of sets. In mathematics, a function is a relation from set A to set B. Every element in set A has a unique image in set B. If every element in set A has a unique element in set B, this means every element in set A maps to some element in set B. Note that no element in set A should be left out. To understand better, we need an example. We know that the relation from set A to set B is the set of ordered pair in the form of A comma B. Now consider two sets A and B in which set A has element 3 and 5 and set B has element 18 and 30. For this, take a relation B is 6 times A, that is B equal to 6A. And this is how we can write in set builder form, set of all ordered pairs A comma B in which B equal to 6A. Now look at an arrow diagram to represent the relation B is 6 times of A. We know that 6 times 3 equal to 18, 6 times 5 equal to 30. We see that two elements 3 and 5 are mapped. Also, each of the element in set A has unique element in set B. So 3 has an image 18 and 5 has an image 30. We can say every element in set A is mapped and has a unique image in set B. Finally, we can say that this relation from set A to set B is a function. Now look at sets A and B again. Set A has element 3 and 5 and set B has element 18 and 30. Now let us consider a relation B is the multiple of A. We can write in the set builder form like this. Now look at an arrow diagram to represent the relation B is the multiple of A. In this arrow diagram, both the elements 18 and 30 are multiple of 3 and 30 is the multiple of 3 and 5. Does this relation satisfy a function? In the arrow diagram, element 3 in set A has not a unique image in set B but two images 18 and 30. Element 5 however has only one image in set B. Since one of the element has more than one image, we can say that this relation is not a function. Now let us consider another sets A and B. Set A has element 3, 5 and 7 and set B has element 18 and 30. Let's take an relation B equal to 6A. Is the relation B equal to 6A from set A to set B a function or not? Can you draw the arrow diagram for this? Yes, this is the arrow diagram. Then what is the arrow diagram tell us? Both element 3 and 5 mapped with each element 18 and 30 respectively. 3 has an image 18 and 5 has an image 30. But 7 is not mapped to any element, so 7 has no image in set B. Every element in set A has not an image in set B, so this relation is not a function. Let's take last combination, set A and set B. Set A has element 3 and 5 and set B has element 18, 30 and 42. For this, let's take a relation B equal to 6A. This is how we can write in a set builder form. Now, look at an arrow diagram to represent a relation B equal to 6A. Does this relation qualify function or not? What is the arrow diagram tell us? Both the element 3 and 5 mapped with unique element in set B. 3 has a unique image 18 and 5 has a unique image 30. No element in set A left out. But here is an interesting thing that the element 42 in set B is not an image of any element in set A. Does this relation of function? Since every element in set A has unique image in set B, so we can say that this relation from A to B is a function. Note that every element in set B need not be an image of an element in set A. There is only one condition for the relation to be a function is that every element in set A has unique image in set B. So we can conclude that every function is a relation, but every function may or may not be a function. We can say that function from set A to set B is a relation in which every element in set A has unique image in set B.